Okay, now I want to look at the rational exponents of numbers. And we will do 3 examples in this video. So once again, a rational exponent is when you have an exponent that is a fraction. And in this case, my base is simply going to be a number. And I want to simplify this so it's not an exponent anymore, but simply a number. What I'm going to do, and the easiest and best way to determine what this number is to convert this rational exponent into a radical. Most of the time, I have a much better feel for numbers and radicals than with rational exponents. So here's my radical. My base 9, of course, goes underneath the radical. And now I have to look at my rational exponent. If you recall, the denominator of this exponent becomes the root of my radical. So the 2 goes there. Now, of course, I'm not going to write a 2 there because for a square root, we don't write the root of 2. If there's no number outside this radical, that means it's a square root. There's really a 2 there, but we don't write the 2. But then, the numerator of the exponent, I actually have 2 choices. I could take that 3 and put it under the radical as an exponent on the 9, and that's perfectly fine. But for me, the problem becomes much easier to determine if I just take my whole radical and I put the exponent of 3 outside this whole radical. I call this root first, because what I'm going to do is I'm going to take the root of 9 first, and in this case the square root, and then I'll apply the exponent. Whenever you take the root of a number, the number gets smaller, so therefore the math is a little bit easier. So in this case, square root of 9 is 3. So I still have my exponent of 3 on the outside, and now 3 cubed is 3 times 3 times 3, which is 27. So 9 to the 3 halves equals 27. Here's a second example. 16 raised to the 3/4 power. Once again, you might want to pause this video, and if you think you can do this on your own, go ahead and try it, and then you can check and see if you did it correctly. Once again, I'm going to convert this into a radical, and then do what I call root first. So inside my radical is going to be 16. Now what is my root? My root is going to be the denominator of this exponent. So in this case, I'm looking at the 4th root of 16, and now the numerator of the exponent I'm going to place way on the outside of the radical. So now I have the 4th root of 16, and that quantity is going to be cubed. So the 4th root of 16 basically says what number times itself 4 times equals 16. Hopefully you realize it's going to be 2, because 2 times 2 times 2 times 2, 2 times 2 is 4, times 2 is 8, times 2 is 16. So the 4th root of 16 is 2, and I still have my exponent of 3. So now 2 cubed, 2 times 2 times 2 is 8. So 16 to the 3/4 root equals 8. Now let me do one more. This one is a little trickier. First of all, I'm looking at a negative number, and I'm going to put that whole negative number inside parentheses. It's going to be raised to the 2/3 power. Now let me just, as a learning point, give you another problem that looks very similar, but is really not the same. If for some reason I had written negative 64 raised to the 2/3 power, these are actually very different problems. The parentheses makes all the difference. For this second problem, the 2/3 is the exponent, the minus 64 is the base. The negative number is not part of the base. So if I were to do this problem, I would figure out what the 2/3 root of 64 is, and then I would just tack the negative on at the end. This one up here, the negative sign is actually part of the base. Oftentimes students struggle with negative signs. So let's go back to our original problem. So once again, I'm going to convert this into a radical. I'm going to put negative 64 under the radical. If I was doing this second problem, well, I could just do it for fun. I would have the negative way outside, and then to convert my 64 to a radical, I simply put 64 under the radical. Now, hopefully by now, you've learned that the 3 becomes my root. And I'm going to do root first, so then the exponent of 2 goes way on the outside. And if I just want to also do this one, I would also put the 3 here and the 2 way on the outside. So my original problem now, I'm saying the cube root of negative 64. First of all, some of you might be worried about having a negative sign under a radical, but remember the key is the root. If it is an odd root, it's no problem having a negative sign under the radical. If it happens to be an even root with a negative under the radical, then we have problems. So in this case, we ask ourselves what number times itself 3 times equals negative 64. And actually, negative 4 times itself 3 times equals 64. So I have negative 4 squared. For this second problem, that negative is still way out front. Cube root of 64 is 4. Now for this original problem, negative 4 squared is 16. For the second problem, it's 4 squared, which is 16. And then you tack on the negative, so it's actually negative 16.